the following sequence converges to 1. So if you have a sequence 1/2, 2/3, 3/4, and so on, you see that the terms of the sequence are approaching 1. In this case, we say that the sequence converges to 1. The general term has the form n divided by n plus 1. So as n goes to infinity, this general term approaches 1. You can get this, for instance, applying the L'Hopital rule. Geometrically, what you have is that the function f of n equal n over n plus 1 has a horizontal asymptote. You see the graph of this function consists of discrete set of points, this dotted curve. So it approaches the horizontal asymptote y equal 1. Sometimes people like to visualize the sequence not as a dotted curve, but using horizontal, like short horizontal bars. It doesn't matter. There are many ways to visualize a sequence, but in either way, we are talking about horizontal asymptote. Okay. Now let's look more closely what we mean by the sum of a series. The first question is, can we add infinite number of terms in mathematics? Well, as you know, the operation of addition, as you learned it in elementary school, you add only two numbers, or if you add numbers sequentially, every time you add two numbers, but this way you can add finite number of numbers. Can we extend it into adding infinite number of terms? Let's see. Here's an example. Suppose you have a large cake and it's too large for you. The first day you eat 1/2 of that cake. The next day you eat half of the remaining portion. That is 1/4 of the total cake. So now you are left with just quarter of the cake. On the third day, you eat half of that remaining part, which is 1/8, etc. So every day you look at the remaining portion and cut it in half and eat 1/2. Will you ever finish it? That's not such a simple question as it might appear. It's actually open to interpretations. First of all, of course, if you have only finite amount of time, you will never finish it. But here's a more interesting question. If you have infinite amount of time, will you ever finish it? Well, if you think about it, no matter what day you choose, there is always some leftover. So it appears that you will never reach the state when no cake left. But you can get to that goal as close as you like. Now let's look at this numerically. Okay, so let's track the amount of cake finished as well as the amount of leftover. Okay, the first day you eat half of the cake and half is left. The next day you eat, so you eat 1/4 of the cake, so the total amount eaten is 1/2 plus 1/4, which is 3/4 of the cake. It appears in this example that it's easier actually to track the amount of leftover. Okay, so the third day, so you eat half of the remaining amount. So the previous leftover was 1/4. You eat half of this, so you eat 1/8. So now the amount of leftover is 1/8. And 7/8 of that cake is finished. On the fourth day, after the fourth day, the amount of leftover will be 1/16, and 15/16 of that cake is finished, etc. Okay, so you see the amount of leftover, it's approaching 0, but it will never get there. Okay. We can write the general formula. So on the nth day, the amount of leftover is 1/2 to the n. And now it's becoming clear that when n goes to infinity, 2 to the n goes to infinity as well. And when you divide 1 by that number, it goes to 0. That's the amount of leftover. So the amount of cake finished is 1 minus leftover. So since leftover goes to 0, the amount of cake finished approaches 1. Okay. All right. So we write 1/2 plus 1/4 plus 1/8 plus so on equal to 1. What we really mean? What do we mean by that? Do we actually add infinite number of terms? We do not. We cannot do it in mathematics. Just like you can never finish your cake. What we really mean is that the running total of what you have eaten is approaching 1. Okay? The amount of cake finished, if you track it across different dates, it is approaching 1. Okay? So what you see in when we write 1/2 plus 1/4 plus so on equal to 1, this is a shorthand notation. We never add infinite number of terms. Okay? We are just indicating that this is a trend, what the running total is doing. Okay? All right. So here are the definitions. So the formal expression, I emphasize formal, a1 plus a2 plus so on, is called a series. Equivalent notation using sigma, we write summation. Index runs from I equal 1 to infinity of ai. So that's the formal notation. Okay. Now, when we write that this series equal to 1, in that case, we use what we really mean is that the running total, the amount of cake finished on different days, is approaching 1. So formally, we write the limit as n goes to infinity of the partial sum from I equal 1 to n of the amount of cake eaten in the first n days, 1/2 to the I. we already computed that partial sum. It is 1 minus the leftover. So that partial sum, so these partial sums are approaching 1. Okay. Okay. So in general, we say that a series a1 plus a2 plus so on, again, this is a formal notation. So we say that this a series converges if its sequence of partial sums, that is the running total, converges to some number. Otherwise, we say that the series diverges. For example, suppose you have a series 1 minus 1 plus 1 minus 1 and so on. Does it converge? Okay, let's look at the running total. That is the sequence of partial sums. Okay, the sum of the first two terms is 0 because you have 1 minus 1. The sum of the first three terms will be 1 minus 1 plus 1. It's equal to 1. The sum of the first four terms will be 0 again, etc. So your running total will be an alternating sequence, 1, 0, 1, 0, and so on. Clearly, the sequence does not approach any specific number. So the sequence diverges. Therefore, the series a1 plus a2 plus a3 and so on diverges in this example. Okay. Now, in mathematics, it's very important to work with convergent series. We do not have mathematics for divergent series. We just don't work with them. So if you want to use mathematics in your research, you want to make sure that your series converges. That's the first thing you need to check. Okay. Finally, just some comparison. Okay, if you just track the sequence of pieces that you have eaten, you know, the size of your daily portions is approaching 0. Okay, we say that the sequence 1/2, 1/4, and so on converges to 0. But the series 1/2 plus 1/4 plus 1/8 and so on, you know, the series which represents the running total, which tracks the amount of cake finished, it converges to 1. Note the terminology. In one case, we are saying sequence. When we talk about individual daily portions. In another case, we are saying series when we talk about the running total. And the two things converge to different numbers. In fact, it's quite common when one entity converges, another does not. Okay, here is a visualization. So let's recall that we can visualize a sequence by just a sequence of horizontal bars. So in our case, the height of the first bar is 1/2, of the second bar is 1/4, of the third is 1/8, etc. So the heights of the bars are going to 0. However, to visualize